Standard 3.4, prove trig identities using reciprocal and Pythagorean identities. Okay, so for this particular standard, our goal is to take a trig identity and show that it's true. And a trig identity looks like what you see here on the screen. Looks like an equation, but we're not solving for A. That's not our job. Our job is to show that one side of the equation is equivalent to the other. So we're going to pick a side of the equation to work with. It could be the left-hand side or the right-hand side, but we're going to start with the one that's more complicated looking. Here you might say that both sides look equally complicated. There's two trig functions, but addition, adding two things, is usually harder than multiplying them. So we're going to start with the left-hand side. So our left-hand side, let's write it out, is tangent A plus cotangent A. Now we're going to use substitution to show that it's equal to the right-hand side. Notice that our right-hand side has secant and cosecant, which is made up of sines and cosines. So let's change this to sines and cosines. Tangent A is sine A over cosine A, and cotangent A is cosine A over sine A. So we've done some substituting. The tricky part now is doing some algebra, and this requires us remembering how to add fractions. So to add two fractions together, you need a common denominator. Notice that both of these fractions have a cosine and a sine. So let's consider our first fraction, sine A cosine A. To get a common denominator, you also need a sine A from the second fraction. So we're going to multiply the numerator and denominator by sine A over sine A. Let me color code here so that is the same fraction. Now we want to add that to cosine A over sine A. But again, we want a common denominator, so we're missing that cosine as our denominator. We're going to multiply the numerator and denominator by cosine A over cosine A. And so again, to color code, here's our cosine A over sine A. It's just brought down. And we're multiplying both fractions by something equivalent to 1. You can always multiply a fraction, the numerator and denominator, by the same thing. And we're doing that so we can get a common denominator. Let me even put that in parentheses here. We want cosine A, sine A to be the common denominator. So in our first fraction, the sine A was missing, so we're multiplying top and bottom by that. And the second fraction, cosine was missing, so we're multiplying top and bottom by that. All right, so let's see what we get at that point. To multiply fractions, we multiply across, so we get sine squared A over cosine A sine A. And our second product is cosine squared A over sine A cosine A. Now notice these two fractions essentially have the same denominator, which is cosine A sine A. So we can add two fractions that have the same denominator by adding their numerators. Sine squared A plus cosine squared A over cosine A sine A. Okay. To continue, sine squared plus cosine squared is 1. That's your Pythagorean identity. So this becomes 1 over cosine A sine A. Now keep in mind our ultimate goal. Our right-hand side is secant times cosecant. Secant is 1 over cosine, so we can split this up as 1 over cosine A, and sine is 1 over sine, so cosecant is 1 over sine, so times 1 over sine A. And 1 over cosine becomes secant, 1 over sine becomes cosecant, and this is equal to the right-hand side. So again, you want to start with the one side of the equation and then using substitution and algebra, convert it to the other side. This is standard 3.4, proving trig identities using reciprocal and Pythagorean identities.